streamline the process, an auto-sensing device has been used to sense the machine starts and stops, and subsequently power the dust extraction system on and off. The first part of the process is to cut the frame components to size. The timber has been supplied or has been previously machined to the correct sizes. It is imperative that all components are flat, straight and square. The saw is adjusted to the required length and the set cut and the off cut are carried out. When the material has been cut to length, it should be inspected and marked to ensure the best machining approach, seeking if possible to machine out any defects in the timber. If a number of windows are to be manufactured at the same time, marking and stacking each individual component will speed and smooth the procedure. The spindle is shown initially with the guarding in place. In order to enable a clear view of the machining operations, much of the guarding has been removed. Axminster Tool Centre recommend that under normal circumstances all guarding is used to the full. During the making of this instruction video, with the guarding minimised, all machining operations were carried out under rigid safety protocols and strict supervision. The operation now moves to the spindle moulder using tool group F1. The tenon stop is set to enable repeatable tenon lengths. Set the material to the tenon stop. If your machine is not supplied with a tenon stop, a stop is supplied with a full system purchase. Again, the auto sensor is used to switch the dust extraction system on and off. Ensure that the spelching board is correctly set to support the material during the production of the open mortises. Make sure the component is clamped firmly before commencing the cut. When machining any components, take care that the component is not turned over during the end-for-end maneuver. Note that the operator is pushing the crossfeed table with one hand on a fixed point of the table that is safely beyond the cutting diameter of the tooling, and the other hand is gripping both the table and the workpiece to ensure that the material does not creep during the cutting operation. Tool group F2 has now been fitted to produce the tenons and the counter profiles. Set the tenon stop to produce the required tenon length. Ensure that the spelching board is adjusted to support the material during the production of the tenon. Make sure the component is held firmly before commencing the cut. The tenon stop is adjusted to produce the other tenon lengths. Check the spelching board is able to support the material during the production of the tenon. It does not need adjusting, the tooling diameter has not changed. Ensure the component is held firmly before commencing the cut. Cut the tenons on the alternate ends of the components as required. Where more traditional methods of construction are required, and the inclusion of mullions and transoms are in the design, conventional mortises can be put into the frame components as required. The tenons for the dual window system frames have been standardised at 16 and 19 mm so that standard mortise chisels can be used. The muck groove is machined about the location of the mortises to clean away any breakout that may have occurred. Similarly, it can be seen from the marking out that the mortise is shortened by the depth of the muck groove, that is, the actual width of the tenon. If required, speed jointing can be used on the corners of the main frame, and traditional mortises used for the inclusion of mullions and transoms. The X-feed facility is removed and the machine set for standard moulding. Fit and set tool group F3. Carry out the internal moulding on all the frame components. It can be seen that the in-pressure hold has not been fitted to the moulding fence assembly. This is to enable a clearer view of the machining operations. Axminster Tool Centre would reiterate that the machining for the video was carried out under strictly supervised conditions and would not condone the removal of any part of the guarding during normal operation. Note, as shown here, the mullions and transoms are moulded on both sides. Having completed all the moulding, the frame components can be dry check fitted together. The external moulding is carried out before the frames are glued and pinned. Fit and set tool A1 and mould the muck groove on the external frame components. The same tool is then used as a rebate block to mould the rebate in the head to house the rain hood. Fit and set tool A2, a 10mm slotting cutter to mould the grooves in the sill for the window board and the extended ledge. The window board is normally fitted after the window is installed. There is a 25mm nosing cutter included in the full system to enable 25mm board to be moulded for window boarding. The components can now be dry check fitted and then glued and pinned. When the glue has dried, the frames can be trimmed and tidied prior to the fitting of the ancillary rain hood and the extended ledge. With all the machining operations carried out on the major components, the frames can now be glued up. Attention can now be turned to the ancillary components of the frame. Tool A3 is mounted and set, and the water drip is machined into the rain hood and extended ledge components. Mount and set tool A1 and mould the tongue of the extended ledge. Mount tool A4 and mould the water throw off on the rain hood and the extended ledge. When the glue has hardened off on the frames and they have been trimmed and tidied, the ancillary components can be fitted. The saw is adjusted to the required length and the set cut and the off cut are carried out. Similar to the frame preparation, when the material has been cut to length, it should be inspected and marked to ensure the best machining approach. If a number of casements are to be manufactured at the same time, marking and stacking the components will speed and smooth the procedure. The process now reverts to X feeding on the spindle. Tool group C1 is fitted and set, and the edge fingers are machined in each end of the casement stiles. Tool group C2 is now fitted and set, and the finger joints and counter profile are machined at the ends of the head and bottom rail. Take care that the components are not turned over during the end for end manoeuvre. The X-feed facility is removed and the machining reset for standard moulding. Mount tool group C3 and carry out the internal moulding on all the casement components. Note that the variable grooving cutter in the centre of the tool group is set to provide the required rebate for the glazing component, and subsequently the correct size of the beading for the casement. The slitting saw, C4, is mounted on the spindle and set, and the beads parted off. Although not shown in the video, the beads are normally mitered prior to fitting. The shadow of the end of machined component profile provides the exact cut-off point. With the beads removed, a dry fit can be carried out, and then the casement components can be glued and pinned and set aside for the glue to cure. Tool group C5 is fitted and set, and the external profile for the flush sash is moulded along all sides of the square. The profile includes a water stop groove and the groove for the friction stay in the correct place and at the correct depth. If stormproof sashes are being made, tool group C5 is modified, fitted and set, and the external profile for the stormproof sash is moulded along all sides of the square. The profile includes a water stop groove and the groove for the friction stay in the correct place and at the correct depth. Where a spanulette fasteners are to be used, the system is supplied with a Euro groove cutter, tool C6. The tool is fitted and set, and the closing style rail of the casement is offered up to the machine and moulded to allow for the fitting of the spanulette. To overcome the problem of the lock pocketing required for spanulettes, with the full system purchase, a jig is included to enable the pockets to be routed out quickly and accurately. Check that the standoff blocks are set for the correct profile, thus ensuring the top plate will be parallel with the profile face. Clamp the jig in mid-position onto the closing stile rail of the casement, utilising the marks and measurement. Using the alignment block, the top plate of the jig is adjusted to sit directly over the Euro groove that has been cut into the stile rail. Using a 30mm guide bush and a 12mm routing cutter, plunge the pocket between the stops on the plate. The stops are preset to cater for the standard lengths of the Espagnolet lock mechanisms. When the pocket has been created, before removing the jig, use the supplied template, correctly orientated, to mark the positions of the holes for the securing screws and the lock spindle. The retrieved bead having been mitered can now be fitted to the glazing rebates. The profiles in the frame are set to use a 22mm flipper weather seal. Cut the weather seal to the correct lengths, miter the ends and press the seals into the grooves. Here are some examples of windows that have been completed in their entirety. The friction stays, the weather seals, the Espagnolets and furniture have been fitted. The sash closing sequence shows a stormproof and then a flush sash type.